Hi viewers, before watching this video, please subscribe it. Don't forget. Okay, so my name is Sri Ramalu, DL in Physics, Degree Lecturer in Physics. My YouTube channel is s.s space physics. So S and S are both capitals and P is also capital. Okay friends. So today's topic is transfer nature of EM waves. Transfer means perpendicular nature. What is the perpendicular nature of EM waves? Now consider the case of electromagnetic waves in which component of E and B vary with one coordinates only x and also with the time t. That is, E is a function of x comma t, B is also a function of x comma t. So that means E and B only these two depends on x and t only. They do not depends on y and z, means along y direction and z direction. Okay, these two are the function of x and t. So their position changes along x and t, x direction and time with time. Now, but electric and magnetic fields here, and we have to write. Please write it. Electric and magnetic fields are perpendicular to each other. So when electric field and magnetic fields are perpendicular to each other, in vector quantity, perpendicular formula is in vector components in vector. If A is a vector and B is also a vector, if these two are perpendicular to each other, then their dot product must be 0. Okay, when these two are perpendicular to each other, then their dot product is 0. Here also dot product is 0 is taken. And so del is I into dou by dou x, j into dou by dou y, k into dou by dou z plus, okay, dot. E means is also vector quantity, and it also explained as I ex plus, sorry, here j is not written and here k is not written. I j k you must write. Okay friends, here it is j, here k into ez, and the dot product. So if you take the dot product, simply I coefficient multiply, j coefficient multiply and k coefficient multiply, then you can get this one. And see here, so just now what I told you, E is a function of x and t only. It is not function of y and z. Then these two components are also 0. Okay, why? Because these two cannot be on these two E value cannot depend. So that is why this and this 0. When those two things 0, then dou E by dou x is also 0. When the differentiation of one quantity is 0, when that quantity is constant, then only the differentiation is 0, isn't it? Okay, so we know already in the we know in at lower classes also. Suppose there is a constant c, and if you differentiate with anything, then its time is 0. That means it indicates constant. Like this also here. Similarly, we can prove that del dot b is also in this manner. And here also not written j and a k. Please write. Don't forget. Sorry for this mistake. Okay, and take the both side dot product and write it. And here also this term and this term 0. Why? B is also, it is a function of time and distance, but here we don't have time but we have the distance. So these two components are 0. Then what happens if you substitute these two components 0, then this is also equal to 0. How you know? Dou b by dou x is not 0, means plus 0 plus 0. This term 0, this term 0 is equals to 0. Then what you can write? Dou b by dou x is equals to simply is equals to 0. Then b is constant. Okay. When one quantity differentiation is 0, means that quantity must be a constant. Okay, so here let it is equation 1, it is equation 2. From equation 1 and 2 are obtained on the fact that the derivative of E and B with respect to y and z are zeros. What I said just now. Okay, Further, let me take curl. Okay, by using curl also. Here we have to prove with all the 4 Maxwell equations. Already we proved with the 2 Maxwell's equations. Now with the 4 Maxwell's equations. Next, third Maxwell equation. What is the third Maxwell equation? Del cross E is equals to minus dou B by dou T minus C, it is written del cross, and in determinant form we have to take. Okay, so del cross E, del vector quantity, and it is I into dou by dou x, j into dou by dou y, k into dou by dou z. Okay, so this row is belongs to this. After this, what you have? E, you have its I coefficient is ex, j coefficient is ey, k coefficient is ez. And now apply the matrix. Matrix, how we apply? I into, when we take I outside, then this row and this row cancel, this two column and this row is cancelled. Then let it is A, B, C, D, and take AD minus BC. AD minus BC. Yes, AD is taken after minus BC. B, first write this into this. Okay, first a differentiation term, and then only E term we have to write. Similarly, minus into J, this column and this row cancel. Then it is A, B, C, D. A, D minus B, C. Like this you have to write. Okay, so AD over minus, after minus BC. Okay, similarly we can write K into also. Okay, and is equals to what you have? Is equals to what you have? You have dou B by dou T. B is also vector quantity. It can be written as I into Bx plus J into By plus K into Bz. And dou B by dou T means I into dou B by dou x, J into dou B by dou x, K into dou B by dou x, dou T, not x. Okay, so see, so this is written in this manner. Okay, and it is multiplied, then we got this one. Now taking I coefficients only on either side. Why? I coefficient has a x component. Only electric field or magnetic field travels along x direction, not along y and z direction. So that is why you have to take only these components. So here I coefficient, this one, it is I coefficient, it is I coefficient. Make these two equal. Yes, with a negative, and remove the I values. It is like this. Okay, the components of E vary only with x. Okay, only with x. So here you don't have x, here also you don't have x, so this term and this term 0. Then this is equals to 0, isn't it? Right? When these two terms 0, then this is equals to also 0. Okay, this is 0, this is 0 means is equals to 0, and it is minus. If we bring this minus, then this is like this. So dou by dou T into Bx 0 means B must be constant. Okay, so similarly, taking curl B, we can show that Ex is constant. Okay, so that means it is the fourth equation, Maxwell fourth equation. By using fourth equation also we can show like this. Hence we conclude that Ex and Bx are constant regards to time and space. Space means x. So their components are static components, and hence no part of wave motion. So thus E is equals to, so this is the final one. Why? Ex is, it is a constant term, so we do not take. So then E is equals to J into Ey plus K into Ez. B is equals to J into By plus K into Bz. So finally we write this equation without x term, as vector E and B do not contains x component. Hence x is the direction. X is what? It is a, x is direction being the direction of propagation. So that means this wave and this wave is traveling along x direction, that is why x component is not there. Hence Maxwell's equations or Maxwell's electromagnetic waves are purely transverse in nature, means they are perpendicular to each other. So perpendicular to me means, suppose it is x direction, it is yz, E wave is traveling like this, let it is E wave, then B wave travel like this, perpendicular, it is a B wave, and C it is varying in z direction, it is varying along z and E is varying along y, but no changes along x, no changes, okay, only traveling. Okay friends, so this is the transverse nature of EM waves. Thank you friends.